Hey again, guys, and welcome back. Today I want to talk about this little unassuming sensor, which is the DHT11. It is a humidity and temperature sensor, and I thought this thing was going to be kind of a pain in the butt to work with, but really, because of Arduino libraries, it's super simple. So these are about two or so dollars on eBay. But if you bought one of these like multiple Arduino sensor type kits, you actually already own one. So you can start this project right away. And if I can find it, here we go. It's right there. So the first thing you'll notice is that this has 4 pins, and as does this, but only 3 pins come out. And that's because this is actually a 3-pin device. I'm not quite sure what this second one from the right does, but it's not connected, and I had this working. So the first place to start would naturally be the data sheet. So let's take a look at that. Here I have something that you young guys haven't seen in a long time, a printed data sheet. So the data sheet usually gives us more information than we need as hobbyists. If you understand this information, it's pretty good, but I'll show you, you don't really need to know too much about your device before you can actually start using it. So there's a nice little intro here, and you guys can read that if you'd like. Here's some tech specs. Okay, so it goes from 0 to 50 C, so it may not be a good idea if you want it like outdoor temperature. And also 20 to 90% humidity. Accuracy 5% on the humidity, 2 degrees C on the temperature. So not super accurate. But again, this is all nice to know, but not need to know stuff unless you have a specific application in mind. This page here, page 5, and I'll link this in the description below, this is the most important part here. It actually shows you which pins you're going to use and what they do. So pin 1, if we set up our sensor like this, so pin 1, the first one here, VDD, which, it does mean something specific, but for our case, it just means the positive voltage. Second pin is our data pin going to our microcontroller. And they see here that you have a 5K pull-up resistor. Okay, and there's a note here underneath. So that's pin number 2. Pin number 4, the ground. Simple, simple. If you read the little description here, it'll say when the connecting cable is shorter than 20 meters, that's, a lot more in feet. 5K pull-up resistor is recommended. When it's longer, choose an appropriate pull-up. And I can see that this Arduino kit one here has a resistor here. And it is 103, that's 10 with 3 zeros is 10K. So I think that's more of a catch-all. For us though, I think I'm going to leave it without the pull-up resistor and see if it works. So power and pin, so 3 to 5.5 volts DC, so that's another thing that's important to know. It's great because Arduinos run somewhere between 3.3 and 5 volts, generally speaking. So a 5 volt Arduino will be perfect for this. And also, don't send any instructions to the sensor within a second, so you have to always delay your code for a second when you start using this. One capacitor valued 100 nanofarads can be added between VDD and ground, so over here, for power filtering. So we might do that in our final product, but for testing, we're going to see if it works without it. Okay, then here it starts talking about the communication protocol, which is all well and good if you're a programming genius. But if you're like me and just are more interested in the hobby side, building things and then learning how they work after, then all we need really is to check to see if there's any libraries. So for this, I'm going to be using the Arduino Uno. I find the Arduino Uno is a perfect prototyping platform because I believe it's the most common Arduino, and so you'll be more likely to find something that works specifically for it. It also has built-in USB, so you need to just plug it in. It's got a whole bunch of pins you can use, so I think we're going to use this sensor and this Arduino. So we know for a fact that we need 5 volts on this pin here. Okay, so And this will be a little rough. This is why these guys are a lot easier for prototyping. But I don't want to rely on the fact that people bought that one. If I struggle with something, I want you guys to be able to learn from it. So then we need a ground on the other side. And again, our Arduino provides this. So ground here. And ground is right next to 5 volts. There we go. So that should be fine for that. And then we need to connect this pin, the second pin here, to somewhere on our board. But usually the example sketches, which is what we're going to do first if we can find them, tells you to put it on a certain pin. So we're going to wait until we get the example sketch put in, and then we're going to see where we need to hook this up. So I guess the next step now is to go over to the computer and see if we can find a library. So here we go on the desktop. We're going to open up Arduino. New version of Arduino. Nah, we'll do that later. That's fine. So it opened up with the Blink sketch because this was the last thing that I had going. So now we go up here to Tools and we go to Manage Libraries. And my first step when I have a new device is I just do a search. So here we go, DHT11, and I saw this DHT sensor library by Adafruit. So it's for the DHT11, 22, etc. temp and humidity sensors. So that's pretty good. I installed that. And then I went over here. So you just click this little, there would be a little install button here. You go over here and go File, Examples. Go down DHT sensor library. And here we go. We've got 2 examples here. So we'll just go to the unified sensor. All right. And this gives us a whole bunch of stuff. Now this is very verbose. This software, I mean, this program seems very daunting. But if you just go line by line, it's really not that bad. So here are the comments. They tell you who made it, which is good. Requires the following Arduino libraries. The DHT sensor library. Well, that's where we got it from, so that's good. And then there's another one here. Adafruit Unified Sensor Library. And I actually tried to put this into the libraries manager, and I didn't get anything. See, it's not really there. Oh, it's there now, but I think it wasn't before. But anyways, what's good is that it tells you to just click this GitHub repository, and you just put that file unzipped in your library folder in the place that you installed your Arduino software, and then that's all you need to do. And then here we see the Adafruit sensor library is included, the DHT library is included, and the DHT-U library is included. So that's what these mean. So if we want to use the DHT on our Arduino, we're going to need these. Define DHT pin 2, so the digital pin connected to the DHT sensor. So here it tells you to use pin 2. Pretty easy. And then you have to uncomment the type of sensor in use. So I'm going to uncomment the DHT11 because that's what we have. And I'm going to recomment the DHT22. That's done. Okay, so see guide for details with sensor wiring. I don't think we need this, but it is a good idea to go check this out. So then it just specifies our DHT pin, our DHT type. And this is a command of the library. So we also set a delay, and the delay comes in later on. So then in our void setup, so now this is the code that runs only once. We want to begin serial communications. That's good. And we also want to begin our DHT sensor. So this is a DHT command. You don't have to worry about this. If you just copy this into your new sketch, you'll initialize the DHT, which is good. All right, and then all this here, the serial print in, it'll basically tell you what your sensor is connected and the information on it. So this here is not very important. This is probably important here. Sensor T sensor, DHT temperature get sensor. So you probably need all that. But the serial print, you don't need this in your sketch if you don't want the information in the serial text file. Then it gets the sensor for the humidity, and then prints the humidity stuff on the serial monitor, and then it sets your delay milliseconds. So it takes the minimum delay needed by your sensor and divides it by 1,000 to get the millisecond value. So this is all so far. You can delete all of this stuff here. This is not necessary for your own project, except for this line. You probably need to keep that. Now, void loop, this is what happens continuously. So we want to delay by the minimum delay that we have already set here from your sensor. These sensors cannot be pulled ad infinitum. They need a little bit of time to recover. So sensors event T event, and then you go get the event. DHT.temperature, so the temperature sensing portion, get the event. Okay, so it tells you if there's no event, just print there's an error recording the temperature, or else print the temperature, the word temperature, then the actual temperature, and then the degrees C after it. So basically, if you want to go get that information, it's right there. This is the command you need. And then same thing for the humidity. So if there's an error, or else write humidity and event.relative humidity. So this is all telling us how to use the DHT11 sensor. And in fact, if I select now my Uno and I go pick the port, I believe it's COM5, and then I use I believe it was the AVR ISP. I should be able to put that in my Uno. Okay, and so now it's successfully uploaded. I just need to go connect my pin 2. And see what happens in the serial monitor. So tools, serial monitor. Would you look at that? It's giving me my temperature and my humidity, and it's going pretty quickly because that delay is the minimum delay. We can actually increase that delay, and I think it might use less current. But right now we've got a DHT11 working, and that took us very little time at all. And I have very little knowledge of how it works, and yet these libraries make it so that anybody can work with these things. So I encourage you to try it and see if you can get it running. And I think in the next video in this project, instead of having this on our computer screen, I want this in an LCD. But that's it for now, and I thank you very much for watching.